What can be concluded from a symmetrical distribution of exam scores? Either that A, most of the students had relatively high scores, B, most of the students had relatively low scores, C, about 50% of the students had high scores and the rest had low scores, or D, it's not possible to draw any conclusions about the students' scores. Okay, so let's start off by having a look at what it means for a distribution to be symmetrical. Now, there's a number of graphs that I could draw that are symmetrical. So I'll do a few just so you get the basic idea. So here are three symmetrical graphs. And the idea is that if you were to draw a line down the center of any one of these, what you would see is that there's a mirror image to either side of the center line. Now that center, or that middle line, is the median. And so the idea is that the median cuts off the upper 50% from the lower 50%. Same is true here, and the same is true here. Okay, now we've got three different symmetrical graphs here, but it would help to answer this question by having a look at something that is not symmetrical, just so we can see what it is that the symmetry actually does. So let me give an example where we've got, let's say that there was a quiz where there was 10 marks possible, and these are the scores that people got on the quiz. So a few people did really poorly, 1, 1, and 1. They got 1 mark out of 10. Maybe somebody got a 2, somebody got a 3, and then one person did exceptionally well. They got perfect. Now, if I was to turn this into a frequency distribution, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to have 3 1s, 1, 2, 1, 3, and then none of these, and 1 10. And if I draw this, it's going to look like this. Let's put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I've got 3 1s. So here is the frequency of 3 people who scored 1. I've got somebody who scored a 2, somebody who scored a 3, and then finally down here at the end I've got that one person that got a 10. Now this is definitely not symmetrical. I can't draw a center line where I get the same look to either side. Where incidentally would my center line be? Well, the center line is just the median, and so if we have a total of 1, 2, 3, 4, 5, 6 different scores, the center line is going to be in the middle of those 6 different scores. So you can see it's going to be right there. There are 3 scores that are worth less than that, where the dash line is, 3 scores that are worth more. That happens right between the 1 and the 2. So my median is going to happen right here. So you can see that when I get my 50-50 point, I'm not looking at a case where it's symmetrical to either side. This side here does not look anything like this side here. Okay, so let's have a look at what this tells us. In every single one of these graphs, all of the symmetrical and the non-symmetrical one, 50% of the people got below the median and 50% of the people got above the median. That's true for all of them. That's what the median is. It always cuts things off 50-50. However, the mean in a symmetrical graph is also in the same spot as the median. When it's a symmetrical graph, for a symmetrical distribution, the rule is that the mean is the same as the median. So that's the same here, here, and here. They're all equal to the median. It's not going to be the same here. The median is down here, but what would the mean be? Well, to get the mean, I need my sum of x. So I'm going to do 1 plus 1 plus 1, that gives me 3, plus another 2 is 5. This brings me up to 8. This brings me up to 18. I've got a total of 18 divided by 1, 2, 3, 4, 5, 6 scores. So my mean is going to be 18 divided by 6. That is 3. I've got my mean happens right here. Here's the average for this group of people who took the test. So more than 50%, this 50% plus this little bit here, more than 50% got below the average, and less than 50% got above the average. Whereas when I'm dealing with one of these symmetrical distributions, 50% got above the average, 50% got below the average. Same as here, and the same is here. So when you have a symmetrical distribution, because the mean and the median, the center and the average are in the same spot, you can say that 50% of the students had high scores and the rest had low scores.